Okay, this is David Zierler, Director of the Caltech Heritage Project. It is Tuesday, September 14th, 2021. Once again, I'm delighted to be back with Charlie Trimble. Charlie, thank you again for joining me today.
My pleasure, David.
Charlie, today, before we go into the narrative of the 1990s, I'd like to return to something you said that was really profound, and it begs for some further explication from you. So when I asked in an earlier conversation about why it took a year and so many consultants to finalize the GPS block program, you explained that it's easy to create something complex and it's extraordinarily difficult to create something simple, which is just such a remarkable thing, and I'd like to delve a little further into it. So both from an aesthetics perspective, an engineering perspective, and also a business perspective, why is simplicity so important?
Well, basically, when you have figured out how to turn something that is apparently complex into something simple, you know that you're dealing with the nub of the problem. I came across this first actually with respect to invention. Invention is principally the process of figuring out a simple solution to a complex problem. We all know it when it comes to writing. I mean, there are a lot of literary quotes about the subject that you can write a long article or a long speech rather rapidly, but to write a succinct one is really very difficult.
And so technologically, why is simplicity important for these applications?
Well, it was important for this application because basically we had frankly limited resources. We needed a solution that could be iterated n times as Moore's law progressed with regards to integrated circuits, and I'm having trouble. I'm having trouble explaining the obvious, actually. And I fully admit that what I suffer from is making things overly complex. But in this particular case, the only way forward was to have frankly, the simplest possible approach that could be implemented in digital form.
I see. I understand. Is there also a beauty in simplicity for you as something to strive for?
Well, it's an aesthetic. It's something that I strive for. I rarely achieve. As I said, I have a tendency to make things much more complex than they need to be. But I find myself most successful when I can be focused on something that is simple, as opposed to the house of cards that comes with a very complex strategy. I mean, there are fewer things that can go wrong if you're dealing with something that's simple.
Right, right. And in this world, in the GPS world, what are some of the things that can go wrong that you were thinking of at the time?
Well, um, second order, um, all right. While at Caltech, I promised myself that that I wanted to deal with the digital domain, not the analog domain, because I didn't have to deal with second order effects, and I wasn't going to come up against the laws of physics if I could reduce the problem to a digital problem. Mm-hmm. And so certainly in this GPS receiver design, I truly wanted to minimize the number of high frequency components and high frequency circuits that often created problems. Well, certainly in those days when you were dealing with individual components making up a circuit, how do I want to say it? The components we use all have specifications, and we think we employ the component within the range of the specifications that are there, but oftentimes there are second order effects that can come into a given component without changing the published specifications. You never really know in a design, at least not without an awful lot of effort, whether the prototype that you have built works because you were just fortunate in the particular components that you were using, or that you were indeed had lots of margin for them to vary. None of this is a problem with regards to digital circuits. I mean, ones are ones and zeros are zeros, and small percentage changes in the operation of any given circuit has absolutely zero effect on the results of something that is digitally designed. We forget about all this now because basically everything, or virtually everything, has been reduced to the digital domain, so that integrated circuits can be basically the chips that make things work. But 50 years ago, or however long ago it was, the world was primarily an analog world.
Right. Charlie, to return.
As a matter of fact,
go ahead, please.
And as a matter of fact, the GPS receivers that were being developed for the government on the military programs were all very, very complex analog receivers.
And you were looking to make this exclusively digital, is what you're saying?
Absolutely. Because that's the only way that I could hitch the wagon to Moore's law.
Right.
And actually, interestingly enough, the the first GPS receiver that we sold had a material cost of about $3,000. By the year 2000, you could buy that function in million a month quantities in Hong Kong as a chip. And so that indeed, over that period of time, that indeed was following Moore's law.
Yes. Charlie, another thing that I wanted to pick back up on is, in your work in Asia, in Japan, what did you learn from a business culture perspective from the other side of the Pacific? What were some of the things that you learned, not just as a matter of becoming more wise unto the world, but that were really useful for you for your own business?
Oh, well, clearly, the technique for driving down factory cost. I mean, the whole environment that I had grown up with, each new generation, you came out with a little more clever block diagram approach, which pulled complexity out of what you were doing. But the Japanese approach of simply rank ordering the material cost of each one of the components and then systematically attacking the most expensive one first was clearly something that we continued to use. And as a matter of fact, the red flag of having a component that was expensive, was truly alive and well on designs going forward. I mean, when you think about it, it's really obvious. An expensive component is probably handmade or somehow handmade, and therefore probably less reliable, and you're going to have more troubles with the specifications. So that was one of them. The other one, which I did use, I learned the Japanese appeared to be to have figured out how to cut the time it took to develop products. Because if you looked at the stream of products that came out of a Japanese company, there were major changes in products on an annual basis. I mean, at Hewlett-Packard, we never replaced a product in 3 years. Basically, a 5-year cycle was as close as they ever came to doing something that was significantly different. But what became perfectly obvious in looking at that, looking at how they did it, was they simply generated a planning pipeline that was several years long, and you stuffed things into one end and at a more or less constant rate, and you got things out the other end at more or less a constant rate, and it just appeared as though they were making incredible progress on very rapid timescales.
What was it about the Japanese perspective culturally, do you think, that allowed for these timescales?
Well, in many ways, they were working from or okay. First of all, my experience really was with what was considered a second-tier electronics company that was customer-facing, largely customer-facing, and they had really very, very few engineers that had the capability of doing original design. And as a matter of fact, the fellow we put into the lab became one of 3 in a lab of 100 that did original design. Now, the original design that was done was quite good, but all the rest of the energy was applied to optimization. This is clearly not a strategy that we ever used or frankly would want to use, but it was a strategy that did work for them. And that combined with the fact that when they needed a component that was new, they had people basically prototype components for them until they got one that worked, and then they could tell them, well, freeze that, never change it, we want to buy lots of them. And so that actually was an extremely good strategy of not having to understand all of the second order effects that were going on with a key component. And we really couldn't duplicate that here because the Japanese manufacturers wouldn't deal with us on that basis. For one, and we could never get it done in the United States. We didn't, it became a problem we didn't need to solve as we figured out how to remove layer after layer of analog circuitry from the original GPS receiver.
Charlie, to go back to the narrative, in the early 1990s, first as a way of understanding the opportunities presented by the Persian Gulf War, what interaction did you have with the Department of Defense prior to 1991?
Well, certainly we developed the what became known as the Slugger, which was the handheld device for the Army that was about the same size as a pair of 7x35 binoculars. It weighed I think 3 pounds and could be powered from 6 D-cell batteries. And that was developed in conjunction with Army Space Command. Down to what was on the front, on the display, the nature. There was either 1 or 2 rotary switches and a couple of toggle switches and a 4-line display, and that was the unit that the Army had decided it wanted. And I think I told you the story of how we were able to win a contract to supply 1,000 units to them, basically a year before Saddam Hussein invaded Kuwait. So that was actually Now, we had gotten reports of how the testing had gone and how it truly worked. But if the events of the Middle East hadn't transpired, that might very well have been the last order we ever sold to the Defense Department. Once Saddam Hussein invaded Kuwait, it was almost immediately when I got a phone call from Larry James in the Air Force. I think he was a colonel at the time. Basically asking if we could make some more of them for the same price we sold the original ones. And that started the sequence of things, which in one sense was positive, but overall, it frankly cost me much more than we gained, because of the fact, the volumes kept going up, and the supply chain from Japan became completely broken because cellular telephones were exploding in Southeast Asia, and we were a second-tier supplier, second-tier customer, and so our stuff got stretched out, and while we did end up shipping a total of probably 10,000 units to the U.S. military, about half of them, by the time the major push through Western Iraq had started, we had so lost control of inventory, and I think, as I told you, under the pressure of figuring out how to build things, my VP of manufacturing had actually broken and started triple ordering everything, something I did not know was going on. I mean, there were no computer systems that controlled inventory in those days. It was still manually derived, and so I only found out that things kept inventory kept piling up as we got into April, May, and June. I mean, it was still coming in, and the Air Force decided that since this was so successful, they should design a new one, and we never got another order, so there was no so it was a major problem for us to figure out how to work our way through the inventory.
Charlie, so I understand. Were there any competitors bidding for this contract, or you were essentially the only game in town?
We were the only game in town.
What does that suggest more broadly?
None of the military suppliers could do anything, and what we had was infinitely better than what Magellan had. So the Magellan units ended up being since all of our production was tied to was going to the DoD. The Magellan receivers were being bought by parents of kids that were being sent to Iraq.
Why was your product so superior? How do you compare the technology from Trimble to Magellan?
Well, first of all, what we had done was to generate something that was incredibly rugged, and and truly work. What Magellan had was an early consumer product. I don't know how else you describe it. Environmentally, the Army had wanted the Army had wanted the unit that they would buy to be incredibly rugged. You had to be able to run over it with a truck, and so the cases were made out of special stainless steel infused carbon fiber, as opposed to being plastic. The shock and vibration was there. The Magellan receiver, I believe, was a one-channel receiver that basically what we had done, the decision we had made is if we gave an answer, the answer had to be right. It turns out that this is not the ideal solution to have with a consumer product, because a consumer would rather believe that you were still getting answers even if you weren't. I mean, there were times that we were getting, after the war, there were times when we were getting a lot of flack from the fact that, or a lot of complaints that there would be a little light that came on that said lost GPS signal. Well, none of our competitors had one of those things. And so we finally had to come up with a demonstration that showed that the receivers that didn't show you that they were losing lock or didn't have or weren't giving you the correct answer weren't working is you put a beer can over the antenna and see how long the receiver says that it's working. And in general, what they had done was they had timed things so that they would appear to be working for somewhere between 30 and 60 seconds before they gave any indication. I guess the easiest way to say this is we had a solution that really worked, and there really wasn't any competition. I mean, there wasn't anybody else. The military suppliers could not build, had no ability to build any reasonable number of receivers for aircraft or anything else. And certainly what they were trying to do for soldiers would have seemed ridiculous. A 40-pound pack versus a 3-pound thing that you can carry in your hand. It was a unique product.
Charlie, from that phone call with the Air Force official, what was your sense specifically? What was the military value that this product conferred to the United States in Iraq?
Oh, well, operationally, it was going to make the operation an awful lot simpler. I mean, I think I've already given you the story of how to the first step in that conflict was figuring out how to blind Saddam Hussein, the air defense ring around Baghdad, and there were, I believe, six fundamental stations around that perimeter. It might have been 8, but basically, you had to take out a pair of them within 5 seconds to basically open up a corridor through the defense system to get at Baghdad, and our units were used to do exactly that.
Did that give you special satisfaction that you created a project that was useful to the U.S. military, that would keep soldiers safe, end the war as quickly as possible?
Oh, you better believe it. I mean, yes, absolutely.
Now, when the supply chain started to break down, how much of that was simply because the military was ordering more than you could handle?
No, that wasn't the problem at all. The problem was that that the parts, I had warped the design. We had warped, I shouldn't say I, but we had warped the design of this product to use many of the same components. I mean, first of all, GPS was not totally digital at this point in time. And so there were a whole series of analog components which were also useful in cellular telephones. And so we were buying these parts, and we specifically were going after these parts because they were in high volume, they were highly reliable, and frankly, they weren't all that expensive. So our design was based on it. The market for cellular telephones exploded that fall and winter of 1990. And so it was the Japanese suppliers of these parts that ran into the production limits. And since we were a second-tier purchaser, our orders did not get priority.
So this was really just a matter of unfortunate timing.
Yeah.
Charlie, what were
Absolutely.
what were the takeaways for you in terms of business continuity, in terms of contingency planning? What did you learn from this problem?
Well, it reaffirmed the old adage that more companies fail from success and explosive growth than simply fall apart because things aren't working terribly well. I mean, this was if this had been a commercial thing, we wouldn't have had the problem. But we had committed ourselves to a larger cause, basically, and we tried perhaps harder than we should have to fulfill the set of commitments.
You're saying that with the right effort, it would have been possible.
What?
With the right effort, it would have been possible.
No, it would not have been possible. We should have we should have done what most other businesses do and not not try not try as hard.
Charlie, overall, what was the financial impact of this entire process?
Well, I came very close to losing the company in the spring of '91. We did make it through, but it certainly the profits that we showed early in the year were really inventory profits, and it was frankly a lead weight. It was a millstone around the neck. So I almost lost it in the summer of '91.
There's a certain irony that the company almost went under because it was too successful. Its products were too good. The military wanted too much.
Well, there is an irony, but there are lots of ironies in life.
Charlie, how did the company recover? How did you steer it back to success?
I believe that again we cut salaries. We focused really hard on the set of things that would produce income, and it's just hard work. There's nothing in business, especially for a small company, that is monotonic.
What do you mean by that, Charlie?
Well, something is monotonic when the trajectory is always in the same direction. There are ups and downs. Clearly, if we weren't pushing as hard to grow something very, very major, if I had been more conservative, things clearly would have been different. But this is where the complexity of basically the business approach comes into play. We were small, and yet in some respects we had several different product lines going on. Clearly, we had to reallocate resources between the product lines. I can remember having off-sites where we looked at what was likely to happen and what we wanted to have happen, and then started focusing on how to close the gaps. This is certainly not. This would be viewed as a high business risk approach to growing something, because not very much has to go wrong for the for the structure to economically collapse. If it works, it's great, but and perhaps it's partially my own failing that I didn't figure out how to have a larger ballast of resources to take care of some of the bumps, but in many respects we were still, even though the company was, well, at that point it was north of $50 million, but north of $60 million in terms of revenue, but and it was growing very, very rapidly, but there weren't all the controls in place to I mean, we still didn't at that point have a computerized inventory control system. We hadn't yet bought the manufacturing line from the supplier of Pioneer that allowed us to run our prototypes on the same line that we ran our production. So you can say that that I probably was following a far more risky strategy and a far more risky approach than sheer prudence would have dictated.
Charlie, as you were looking to recover the company in the early to mid 1990s, I'm curious the extent to which the previous acquisition of the navigation systems division of TAO and the New Zealand company Datacom Software Research Limited, in what ways was the acquisition of outside companies important to Trimble Inc.'s overall health in the 1990s?
Well, we clearly won, although the New Zealand operation was small, and so winning. It probably represented about a 10. It was less than a 10% factor, and so even though it was doing well. Certainly, the software that was coming out was really important for the GIS market, and certainly the farm club aspect of engineers and managers that could move to the United States was quite positive. It was positive, but not in itself. I mean, the thing that made the company, and actually, what it's really the high precision, high accuracy survey / construction market situation that drove the profitability of the company. The TAO thing, the biggest benefit I got out of the TAO acquisition was a gal by the name of Ann Signer, who later was to manage the interface with Washington and did a brilliant job of it. But we never really made any money in the systems business. No, it was the stepwise improvement of being able to rapidly get position to the sub-centimeter level, and then to get it on a moving platform, and then to be able to guide those platforms. If you can control or if you can provide the controls to a road grader, you certainly can speed the whole process of putting in a new highway. So really the money that was generated, or the growth margin that was generated from the business, all came from the activities that went back to the original survey, and frankly, the use of the GPS system that was not part of the government's design.
What new markets were you looking to get into after the Persian Gulf War?
Well, certainly to move from survey to construction, to the GIS market, things like how do you provide the displays that allow people that are running these heavy pieces of equipment over landfills to know that they've run over every square inch of the stuff 3 or 4 times in a relatively uniform way. Mining, turns out that basically picking up the data when the explosives are set off that crush the rock, to basically give an indication of you pick it up during the drilling process so that you know at what levels you're going through ore seams and that sort of thing, and then to be able to use that information to know to generate the strategies for processing the dirt. It turns out that in gold mining operations, in high quality gold mining operations, people are dealing with extracting grams of gold per ton of dirt. So, it's a major process. And if you can make that more efficient, it works better. But during this whole time, this was when we were realizing and we were actively pursuing the fact that GPS was an information utility. It was a utility that provided you with the ability to time tag events and to geotag features, and so the thrust. The GPS receiver design, yes, improved on an annual basis, not an annual basis, but once every 18 months or so, with the IC cycle. But really, the utility was in the software. The fact that you could receive the GPS signals and process them allowed you to generate the value in terms of the information that was produced, and that was the theme. Precision agriculture, certainly applications like the docking of North Sea ferries, dredging, I mean, basically, all of the large movable platform markets basically, became accessible.
Charlie, when did you first think of stepping down from Trimble Navigation? Do you have a specific memory of when perhaps you were satisfied that you had steered the ship and it was stable and it was time for new pursuits?
Well, you're not going to get the story that you expected to get out of this, because I didn't make that decision. The board that I had used for advice decided that it was time for me to go, and so I was actually jumped, and I was jumped without warning.
What were the considerations? Why did they feel this way?
Well, there was a frustration that I wasn't growing the market fast enough. I had not. I had basically used my board as consultants, and so I had not watched their equities changing over time. The primary cause could very well have been one of these class action suits that hit technology companies, or I think I'm not sure whether they still do with the same frequency or not, but it was a very popular way for lawyers to make money certainly in the 90s. We had a major contract with ComSat. It was a satellite. It was a satellite communication satellite provider, and it was a big contract. It had been announced. It was a $10 million contract, and at one point, I noticed that the receivables were getting high, and so we pushed on them, and the CFO of ComSat said, "Well, you can ship if you want, but we're not going to pay you until this financing goes through." Well, here we're caught between a rock and a hard spot. In one sense, with adverse news, you're supposed to make it public, and in another, anything that we did was clearly going to damage ComSat. And then during this period, one of my direct reports sold some stock. he was aware that this was going on. I mean, this is an absolute no-no. It's an insider transaction. I basically fired him for it, and the penalty, the SEC penalty for doing this is you pay back. I don't remember whether it's all your gains or twice your gains, and so the deal was I canceled a substantial number of stock options that he had to make up this penalty. Anyway, this became the basis of a class action suit, and I had taken the HP attitude towards class action lawyers. I mean, class action lawyers had come after HP, and HP had actually gone to court and defeated them. And so I took the approach that I was going to do that. Unfortunately, the law firm that one of my board members was senior partner on ended up looking like the most attractive defender. And I had said to them in the beginning, all right, we're going to go down this route and we are not going to settle. This is something we have to win. Because if you settle, all you're doing is setting yourself up for another suit. Anyway, this went on, and I think the law firm didn't, got paid for doing all the discovery, didn't get it thrown out on summary judgment, and didn't want to lose on trial. And I really believe that this was behind it. But be that as it may, it happened. And so basically, in a single board meeting, the first thing that was done was we had already talked about sooner or later, I would agree to having an independent chairman of the board. And so the first thing they asked was for an independent chairman of the board. And then they proceeded to do what was their right, which is to remove me. So that's what happened.
Charlie, what were some of the emotions that were going through your mind at this time? Did you feel betrayed? Were you angry? Were you resigned? What were you feeling?
I felt incredibly betrayed. I mean, I had put 20 years of my life into this thing, where basically all of the resources that I could bring to bear, emotionally, physically, intellectually, had been done, and suddenly it wasn't there. I have vowed that if I am on a board with a founder CEO, I will not allow it to happen to him. And I'm not going to name the company, but and I don't actually want this in the report, but I'm actually in the process of making sure it doesn't happen to a founder CEO as we speak. But that's 20 years later. Anyway, what I decided when I finally decided that all right, it was time to move on. That's when I actually went back to Caltech and started looking in the biotech area, and it's how I got involved with this little biotech startup that I've mentored for a long time. But that's how I truly re-entered the Caltech org.
Charlie, before we get to the biotech work, I'm curious about the timing of your chairmanship of the U.S. GPS Industry Council. Was this something that became available to you after you left the company, or this was something that you were considering before all of this happened?
Well, I believe I was chairman before this all happened. Actually, we had Trimble had put together this industry council as a communication mechanism between the U.S. government and the industry. It was originally set up right after the Gulf War when the Pentagon was about to throw ITAR export license controls on GPS because GPS proved so valuable in the Gulf War. And so it was something that we had started. I wasn't the initial chairman. We had somebody else as chairman, just simply to garner to more support, not monetary, but more emotional support. But within certainly by 93, I was chairman, and Ann Signer was carrying the load of making it work. And we played the industry council, and obviously Trimble played a major role in a lot of the unfolding that took place in government policy with regards to GPS.
Charlie, I wonder if you could talk a little bit more about the origins of the GPS Industry Council. First of all, is it a quasi-government organization? Does it have any policy-making abilities?
No, it's simply, it was really very simple. When we were told that we were going to be faced with export license controls on GPS, and it turns out, Trimble was probably getting somewhere between 25 and 30% of its revenue from overseas. They also told us two more things. They told us that they couldn't talk with a single company. They could only talk with an industry council. And the decision had to be made within 3 weeks. So Anne put together an industry council of 7 CEOs that had something to do with GPS, and we showed up in a conference room in the Pentagon in 10 days. And basically convinced the security people that, well, first, that the cows were out of the barn. Secondly, we could be useful in terms of protecting technology for the U.S. government. And I guess third, that the way for the U.S. military to maintain the maximum advantage that it had for a satellite system was to get the world to adopt the civilian side of the GPS system, which the military had the keys to screw up.
What did that mean for you, Charlie? What did that mean?
Well, I mean, they had the availability, they had selective availability, so they had the ability, they knew how to basically disable civilian GPS. Now, we knew perfectly well that they couldn't do it because they couldn't afford to have P-code receivers go behind enemy lines, because one of those units might be captured and therefore decoded. So they had to send people behind the lines with CA code receivers, so they couldn't really screw up the signals. So we knew that, I mean, this was an argument that satisfied the people that were really worried about, well, they were worried about the fact that GPS was supposed to be a military system because the military paid for it. And you know, it was slightly embarrassing that the civil side had actually bailed the military out for, I'm using harsher words than I would have used at the time, but had bailed the military out for the Gulf War. And so the industry council basically made sure that the military equities were maintained, and we didn't see any reason why the military equities couldn't be maintained, and we still wouldn't be able to abuse the physics of the signal structure coming out of satellites.
Who were some of the key government partners in this work to ensure that GPS had the best possible policy outcomes?
Well, that was a you would have to ask somebody like Ann Signer for that. But my 20 years later, or 30 years later now, what I'm left with was it was a constantly changing cast of characters. The highest level person, I mean, there are some people that that I think I remember. There's a fellow by the name of, I believe, Bob Bell during the Clinton administration that that we dealt with, having to do with getting the military to give up on selective availability. First, to not use it anymore. I mean, Trimble really didn't care, but to keep the alliance together with people that were making commercial GPS receivers, not commercial, but consumer GPS receivers, it was important that we always maintain a position of what is good for the industry. And frankly, it was my intent to drive the price of GPS receivers to zero, so that this was the best way of protecting the military equity, because it's always hard to compete with a utility. It's almost impossible to compete with a free utility. Mm-hmm. And the fact that GPS was given away for free meant that the Europeans nor anybody else could actually charge for the signals, their signals. And so this truly held up their development, which clearly was to the advantage of the U.S. military.
Charlie, maybe it's an obvious question, but why was it so important to preserve the military's equity?
Oh, because they actually did have the control. And actually, when I think of it, I had to work with the top level. I ended up having to work with the top level civilian leaders in the Pentagon. I mean, they were at the Assistant Secretary of Defense level generally, but I also had contact with the Secretary of Defense, and of course these people changed over time. But they were the ones that could actually set the policy. There was a group at the colonel level inside the Pentagon that really wanted to offload all civilian usage of GPS to the Europeans. And so we were constantly fighting them. And Anne was a good enough chess player that we actually prevailed. The other thing we had to go through was, again, it was a control issue, the whole idea of user fees. Since there's so many people getting so much benefit out of GPS, shouldn't we be able to get user fees? I had to sell the argument twice and maybe three times that the income tax system that we had in place was probably the most efficient way of collecting money from the productivity increase to society in general. You couldn't actually count the beans, but any system that was put together to try to tax individual receivers, first of all, would benefit foreign manufacturers because they wouldn't have to do it, and Ronald Reagan had already promised the world the civilian signal for free. And so virtually all the money that would be collected on a per user basis would be absorbed by the bureaucracy to collect it. And I did sell that to the GAO twice.
And Charlie, if you could explain, you've been lauded for your work protecting the GPS spectrum. I wonder on a technical level if you could explain what the GPS spectrum is and what it means to protect it.
Okay, the GPS spectrum, it's about, the CA code signal, for example, or the L1 signal, is it, what is it? Is it 1572 or 1592? I've forgotten what the number is now. But the civilian signal is a megahertz wide, and you really need more than that. And the military signal is 10 megahertz wide, and you need that. But there are two sources, and so there is a band that the World Radio Telecommunications Conference. Anyway, it's a subsidiary of the UN that basically allocates frequencies around the world. And before the early 90s, it was really a pretty gentlemanly club that debated stuff and allocated things out. It became political when Bill Gates hired two past presidents of work to go around the world and to offer member country payment of their dues, which allowed them to vote, in trade for a positive vote on a large worldwide satellite system. And of course, this predates all of the stuff that we have with Elon and others now, OneWeb, in terms of multiple satellites. They had locked up a majority of the votes before the start of the war. And the Brits and the French took this as a complete affront against Inmarsat. But they lost. So so retribution was that they were going to take, was it 20 megahertz, or I think it was 20 megahertz, it's part of the guard band of the GPS spectrum, and give it at the lower end, and give it to Inmarsat. We had already taken stuff out of the high end of the spectrum for satellite navigation systems, which had pretty much hurt the Russians. But in any event, so this is what they were going to do. And they went around the world, and when we got word that, Anne got word that disaster was on its way because they had lined up all of these people. And I guess, there were 92 people, 92 countries that had paid their dues so could vote. And they had 47 votes. we came into this battle with, our good allies, Russia, Syria, Syria, Tonga, and two others I've forgotten. But and so we started the work with this as the starting point. We knew perfectly well that we had to get the issue remanded to study so that we would be able to go back and reset the whole voting thing later. Unfortunately, of course, England was opposed to us, but Israel, New Zealand, Australia, Canada, Japan, all of our traditional allies, the telecommunications departments, who had no understanding at all what GPS was or did, had agreed to this thing. Okay, so the first part of protecting the spectrum was to keep sections of the spectrum allocated for GNSS from being taken away. The second part has to do with the noise floor. The GPS signals are really very, very faint, and the receivers have been designed, frankly, to pull signals out of the noise. And so if you increase the noise floor, you just make the signal-to-noise ratio worse, and you make life much more difficult for your GPS receivers. And so we went through a series of battles with regards to people that wanted to just use up the noise floor. And so Time Domain was the name of a small company. I think they were I think they were being supported by some other people, but let's not presume that we can tell that. But they had convinced the in 1996, the Telecommunications Act had completely stripped the technical capability out of the Federal Communications Commission, FCC. It was said that you basically ought to be using the technical people in the competing companies that want the telecommunication services. So they had convinced the remaining people at the FCC that the FCC has been allocating frequency spectrum on the basis of frequency. But there is a whole different thing. There is time domain. And if you go to time domain, you suddenly have more spectrum. Of course, failing to comprehend the fact that there was a French mathematician that had mathematically tied the time and frequency domains together, called Fourier. This was the freebie. So yes, we put a lot of effort into this, certainly in the latter 90s.
Charlie, switching gears a little bit, I'd like to ask about some of your advisory work during this time. First, you were a member of the Council on Foreign Relations. Tell me a little bit about how that came about and what you did in that role.
Well, all right. that was a group that that actually was formed basically at the end of the First World War. Lawyers and doctors in New York that were going to try to provide advice to Woodrow Wilson with regards to foreign policy. And it's been a member-selected organization for ever since then. In much the same way that the national academies are member-related or member-selected. And actually, you have to be nominated, and Ann Signer managed this one, and actually it was Bill Buckley that nominated me.
How did you know Bill Buckley?
He found us when we were a small. We were operating out of three, basically garages. Now we had maybe a couple thousand square feet, but there were roll-up doors on each of the three buildings that we were in Mountain View. He had found us, and he wrote an article about us having to do with Loran C. And that's when he found us originally. And later, I had loaned him one of the very early GPS units for his sail across the Pacific. So that was and for that I got to receive all of his novels, which actually he's an awfully good writer.
Did this viewpoint on international affairs influence your thinking of the utility of GPS at a global level?
No, I had the global level. I mean, it works exactly the opposite. Actually, when we were about a $5 million a year company, I hired a vice president of sales that got me into the global arena, and the overseas market was really important to us. No, we were selling. I mean, we had major offices in England, England and Japan. We were selling $3 million worth of stuff into China for oil exploration, so no, we from '86 on, we clearly were a global. We clearly were a global company.
The other advisory work I wanted to ask you about, Charlie, was that for NASA, on the NASA Advisory Council. How did that opportunity come available, and what was some of your work for NASA in that role?
Actually, that came about there were people in government that and NASA who had were well. I really got to go back because the first time we started getting involved with the U.S. government was when we received we received word that there was a rider that had been attached to an Armed Forces Appropriations bill that called for the U.S. government to limit the accuracy of differential GPS in the Gulf of Mexico to 10 meters. I think it was 10. It might have been 5. But anyway. And that actually is what started our involvement and Ann's involvement with Washington, which went on from then on, and it actually was a fellow. Come on, Scott. Blocking on the name at the moment, but I've used the name before in other. Anyway, Scott at the time was Assistant Secretary of Commerce, and we were seeing him because of USTR issues and selling into Japan, and then he was very much involved in the major work battle and the subsequent rollout, where we basically had unanimous approval for maintaining GPS at the following work, but we ended up basically going around the world getting that. Anyway, so Scott at the time was and we had saved NASA's bacon because there was no. NASA wanted to use GPS for the shuttle and the space station, but there was no protection for space-based use of GPS, and we took care of that problem at work for NASA. Anyway. It actually came because of the coup where I was relieved of my duties as president and chairman of Trimble. I was kicked upstairs to vice chairman for a while, but anyway, at that point in time. I am sure it was Scott who got me on the NAC, and actually that was the first time that I had been really involved in that. Although I had gone through. I was already a member of the National Academies, and I had been on a couple of different studies. One having to do with government policy towards R&D that Gordon Moore, I believe, was chairing. And another one that had to do with the issue of the space-based employment infrastructure. So I've been involved in those sorts of things. Anyway, I'm sure it was Scott that that got me nominated onto the NAC. And so this was blocking on his name now. The famous NASA administrator that had been there forever. Come on, boy, names are really escaping me. All right, he was. Come on. All right, I'm not gonna pick up the name. I knew him because I had gone to him earlier, asking him for advice on politically handling the issue with regards to limiting GPS accuracy in the Gulf, and when I described who it was that was behind this, he said, "Well, your problem is you have a 10 hard problem because you've stepped into a political minefield." Well, he wasn't helpful. I did know him, and he knew me, and that probably helped as well.
What was some of your policy work for NASA? What were some of the things you were involved in?
I can't say that I really had any lasting effect. It was rather interesting. NASA was reeling from the problem of blowing up a school teacher. Sending somebody up to the shuttle, and I think that isn't the one, but there was another one that Feynman got involved in. Anyway, there were three of us, an ethicist from the University of California, that has to be on the extreme left of the spectrum, a Catholic priest who was a physicist that ran, what's the name of the Catholic university? Notre Dame, and myself, that were trying to convince the NASA administration that they should stop maintaining the fiction that space was safe. It should be viewed as very unsafe, as all seminal explorations had been. But there was no way that that was going to percolate through. The other one, I was hopeful that the number of NASA centers could be shrunk so that it would be possible for more of the budget to go into the programs and less into the administration. But I clearly was unsuccessful on that one as well. So I guess I have to say that my level of success parallels the level of success of people, for example, that ran the FAA and had as their minimal objective completing a freeway from Washington D.C. to Dulles, which one FAA administrator after another failed to be able to accomplish.
Charlie, if you'll permit me, you have been recognized and celebrated so widely, even during this period of time we're talking about, just to list some of them. You were named Entrepreneur of the Year by Inc. magazine in 1991, CEO of the Year from Financial World magazine 1996. The IEEE gave you the Kirshner Award. You got the Piper General Aviation Award from the American Institute of Aeronautics and Astronautics. You've been elected to the National Academy of Science and Engineering, to the American Electronic Association's Medal of Achievement, the NASA Technology Medal, and even the Golden Gizmo Award from the San Jose Tech Museum. That's a cute one. Of all of the ways that you have been celebrated for your achievements, what stands out in your mind as being both personally meaningful and also technologically and scientifically meaningful, because so many of these awards are given by your peers in the field?
All right. Okay. At the time I was given it, the Man of the Year award was probably the most prestigious of the awards that I've received. I mean, that puts me in the category with Hewlett and Packard and Moore and the luminaries of the Valley. Actually, the most recent one from Caltech, the Van Karman Award.
That's more recent. I was more in the 1990s and early 2000s mode, but yes.
Yeah, I know that one. Well, it's most recent, but it also probably is the one that's most important to me.
Tell me why.
Caltech gave it to me.
That's wonderful. Charlie.
Yeah, and by the way, I do have a Distinguished Alumni Award that I got a long time ago.
Yes.
From Caltech. Yes.
And for the same reason, that must also be very special to you.
It is.
Charlie, in our next discussion, we'll pick up in 2002 when you're named a trustee to Caltech. But my last question for today, at the turn of the century, in what ways was the internet and personal computing revolution of the past decade, in what way did that change GPS from your vantage point?
Oh, well, it allowed us to basically combine GPS with communications. And I mean, the internet, but also the cell phone, because those two have become inexorably linked. And it was the standardization of communication that, when added to the sensor capability of GPS, allowed just a host of new things to be done. I mean, we fought for years and years and years with providing relatively simple radio communication tools so that we could use the differential approaches. But now, I mean, you not only can have the information flowing one way, you can have it flowing two ways, and so the device that the operator is using can couple information that can be collected from GPS with data that is relevant to the job, and so those were confluences that were on the horizon, but had finally gotten to the point that they truly could be exploited.
Charlie, that's a great place to pick up for next time.